Cytotoxic T cells use their TCR, and they are specific. They have a CD8 marker on the surface, which also binds to the MHC, to the exterior of it. But these bind to a target cell and trigger apoptosis. That cell's a goner. Natural killer cells and cytotoxic T cells like to bind to two types of target cells. Cells that are infected with a virus and tumor cells. Is that a good thing for them to kill, to bind to? And yeah, that's a good thing. Those are good targets. Okay, so, but cytotoxic T is adaptive, it's specific, natural killer is innate. Different processes. This shows phases of the immune response. I'm not going to go all through this. This is for your reference, but look, innate responses occur in minutes, adaptive occur in hours or days. And then the memory, days to weeks, and the memory can be lifelong. That's the big picture I want you to get. And this goes through specific things that we have talked about. I'm not going to repeat myself, but this shows different things that happen in both the innate and the adaptive responses, and the adaptive responses yield this memory. Vaccinations, I'm going to go a few more minutes, so just bear with me. The vaccinations for normal childhood diseases have been the primary reason why we have had the extension in the life expectancy. I didn't say that very well. But life expectancy has risen dramatically over the last 100 years, and the primary factor has been the use of childhood vaccinations. 2 or 3 children born out of 5 did not reach the age of 5 over 100 years ago because of infectious disease. And vaccinations have greatly decreased the incidence of those diseases. This shows the drop in diphtheria after the vaccine was put into use. This shows the drop in polio, paralytic polio, after the inactivated vaccine and then after the use of the oral vaccine. This is the Salk vaccine and then the Sabin vaccine. This shows the incidence of measles and a long-term, a slow viral infection that can occur from measles, which is called subacute sclerosing panencephalitis. It's not very common, but the incidence of both measles and SSPE dropped after the vaccine was available. So, vaccination is a good thing. This shows the different effects, a normal response to antigen, and what happens if there's not a response to an antigen. Let's say an infectious agent, a normal response, you clear the agent and you develop immunity. If you don't do that, then you're going to have recurrent infections, right? Innoxious substance, that means things that cause allergic reactions. If you have a normal response, well, normally that's not. You don't want the allergy, but if there's no response, then you don't have the allergic reaction. A grafted organ, normal immune response is to reject it. You have to suppress the immune response so that you have acceptance, so that you become tolerant. Self-organ, if you have a response to it, then you have an autoimmune condition. That's not a normal situation. You want the self-tolerance. Tumors, we have a surveillance system in our immune system. Since NK cells and cytotoxic T cells can bind to tumor cells, we have immunosurveillance for tumor cells. If there's a breakdown, someone who's immunocompromised, like HIV-positive individuals, have a higher incidence of tumors. And that's because their surveillance has gone down. So, immune responses to tumors is an important aspect. Okay, that's that. While you're packing up, I want to show you this slide because you don't have this on yours. It doesn't matter if you have a copy of it or not, it's not on your PowerPoint. But this second lecture deals with the innate response. So while you're packing up, I'm just going to explain this a little bit. You know, the innate is not specific. It's the same things come into play every time you're exposed to a particular pathogen. In contrast, adaptive or acquired is specific, and with the second exposure, you have that booster response. You have a memory response. And every time you encounter that, in theory, you're going to have a faster and a better immune response. You can measure it different ways. Different types of cells are associated with the innate response, and different types of cells with the adaptive. B cells and T cells, adaptive, no question, because they bind specifically to antigen. Okay? But macrophages, dendritic cells, we've got some gray areas there, because the phagocytosis is innate, but they are antigen-presenting cells. So they cross the line, so to say, and enter into the adaptive process. Their innate function, phagocytosis, can occur within minutes. But then they engulf, process, and present antigen to T cells in the lymphoid tissue to activate an adaptive acquired response. So there is some crossover there. Now the rest of this lecture will be a little bit more convoluted. We're going to talk about the innate response in detail. We're going to talk about phagocytosis, and for those of you who have been introduced to immunology before, we're going to talk about complement. I'm going to do it briefly on complement, okay? We're going to get the high points because you can get into minutia with complement. Okay, we're not going to do that. Okay? Any questions? Okay, I'll see you in lab.